Test.
All right, so welcome everyone. My name is Aiden,
My name is Sam.
and we are members of Team 11260 Upper Creek Robotics, and we're here to give you a chassis workshop.
So the first thing to consider when building your chassis or choosing which chassis to design is to analyze the game and figure out what objectives you want to complete and what chassis you might need to be able to complete the objectives. So for example, in Rover Ruckus, you needed to get over the crater to get the minerals. So one chassis design could be our bogey wheel base, which was able to get over the crater.
Also, a very important thing to do when you're thinking about your chassis is you want to think about how it relates to your robot as a whole, and basically how significant your chassis is, and how many other mechanisms you'll need to plan for. And from that, you can designate a certain amount of motors for the chassis. In FTC, you have 8 full rotational large motors, and if you want to have more complex and greater variety of mechanisms, you may have less for your base. You might only have 2 motors for your base instead of a more powerful one that would have 4. A few different kinds of wheels. I have examples here. There are traction wheels, which are very basic wheels, nothing interesting about them. Omni wheels have rollers on the side, so the wheels can move sideways in addition to functioning as regular wheels. And the mechanism wheel is a very interesting wheel design because the rollers are at a 45-degree angle to the wheel, which allows the motors, if you drive them towards each other, so all of the motors need to be independently powered, but it can drive itself right or left, so it can strafe very effectively.
So next we'll go over the different types of chassis. So first we have the tank drive. So the tank drive is the most simple chassis, and it is very reliable, though it is less maneuverable than other chassis types. So there's 3 common different types of tank drives. So the first is a West Coast, which is the most complicated of the tank drives, and it has 3 wheels on each side of the base, with the one wheel in the center being lower than the others, which allows for better turning while also maintaining good pushing power. The next is the skid steer, which uses 2 traction wheels and 2 omni wheels, which allows for a turning radius in the back of your robot, and it's very simple to build, and so it's very easy to do, but it does have less maneuverability again. And then there's a standard chassis with 4 omni wheels in each of the corners, um, which just makes it easier for turning in the center of your robot, and it's just a very solid chassis overall.
All right, next is the mechanism wheelbase. So that uses those special mechanism wheels. It has 4 wheels. Each of them are independently driven by its own motor. And the advantage of that is that you can have your robot move not only forwards and backwards, but left and right with extreme ease by individually powering the wheels. So it's just a lot of added maneuverability, not much different in overall structure than a tank drive, though.
Next we have the holonomic or X drive. This base, it has 4 omni wheels in each of the 4 corners of the robot, angled at a 45-degree, so this allows your robot to move in any angle. Though the problem with this drive is that it has less pushing power, and it has the less ability to drive over some objects.
All right, an H drive, it's really not a very common one. You probably won't see too many out there in the FTC world, but it is a drive that consists of all omni wheels, and it has 4 omni wheels in each corner of the robot, as a tank drive might, but then it also adds additional omni wheel in the center of the robot that's perpendicular to the rest of the wheels, and that allows for the same strafing capability that a mechanism drive would have, but some of the problems with this are you do need at least 1 extra motor for the individually powered wheel, and it also just takes up a lot of very valuable space for building in the middle of your robot.
So lastly, we have alternative drive types or game-specific drive types. So one example is our base here, which is the bogey wheel drive, which allowed us to go over the crater without our robot moving up and down too much. And then we also have a swerve drive, which is generally a more complicated base, and it requires more motors than a tank drive.
Yeah, and so swerve motors can swerve drive. Each wheel can rotate individually on its own axis, so it's a lot of maneuverability, but yeah, a lot of motors and very complex system. So one of the options for starting off and for getting a base is a commercial off-the-shelf chassis. Lots of robotics companies will sell these, such as AnyMark and their Tile Runner chassis, or GoBuilda or Servo City chassis. And these chassis will save you time. They're going to be high quality chassis, and just get that out of the way so you don't have to worry about designing a chassis. You can just have one. However, it really limits you in what the chassis can do. There won't be as many varieties that are available to buy, and they're also quite expensive. I don't know if you can see that, but they're around $600 for the base.
So next you want to make a hand drawing of your chassis once you've decided which chassis you want to go with. So this allows you to make sure that you have room for mechanisms on your robot, and then it also allows you to make sure that you get the dimensions right for when you're starting to prototype your chassis. Here's an example drawing of a chassis.
All right, so another thing to consider when you're building your chassis is how you're going to drive it. So there are three primary options for the drivetrain. That can be gears, chains, or belt drives. Gears are a very simple system, and it's very easy to control the ratios between them. But under certain situations where your robot needs a lot of torque and it could damage the gears, it can wear your gears down. Chain is very variable length. You can adjust the length with the chain tool, and those will hold up pretty well, but you might need a tensioner or something to keep the chain at the tension that you want it. And a belt drive is definitely the least common option, and that would have a belt going on the outside of all of your spinning wheels. So that would be the part contacting the ground, and it would give it lots of traction with the ground, but it'd also be a lot of mass for the motors to move.
So next you have motor placement. So motor placement is very important when designing your robot, because you want to make sure that you have room in the middle of your robot for mechanisms, so you don't put your drive motors in the way of that. And you also want to make sure that you distribute them evenly across your chassis, so you keep a good weight across the robot.
Okay, so structure. Structure is going to be such a key thing for your chassis throughout the season. If you can start off with a strong and reliable, durable chassis, then that's something you don't have to worry about every competition. You don't have to go back and rebuild it. So it's a very good idea to do that. But basically, you want to have structural bars as needed. You can have crossbars, a strong building material, so you're likely going to use aluminum or steel for your chassis. And C-channels are a strong option for just a base part you can buy, which are a metal bar with two perpendicular metal pieces coming out to add structural integrity.
So again, you want to make sure that you design your robot with your mechanisms in mind. So you don't want to put your drive motors or anything in the center of your robot where you might want to put an intake or arm mechanism.
All right, so a problem just everyone needs to be aware of and everyone has to deal with is ESD, or electrostatic discharge. So it's essentially when an exposed metal part of your robot conducts electricity and interrupts the connection between your phone and the brain of the robot, and your robot stops doing what it was doing and loses connection. So exposed metals are a big cause of that. For example, the lander last year, we ran into a lot of ESD problems when one of our metal parts of a robot hit the lander and got the big static discharge. And different, just in general, the foam field and game elements moving along them create a lot of electrostatic discharge. So it's something you'll just need to adapt to. There's not like one perfect way to get around it.
So you always want to make sure that you keep your center of gravity in mind. So you want to make sure that it's low and in the center of your robot to prevent tipping when using large arms like in last year's game, so that you don't tip your robot and render yourself useless.
All right. The last thing to kind of think about when you're deciding how your chassis is going to function is whether you're going to choose speed or torque, and those are two inverses. So if you gear your motors to perform at a high speed, they'll have less torque. High torque will have less speed. Um, and torque is the amount of pushing power that the motors have. So it's really important if you're driving over any difficult obstacles or if you're getting into any pushing situations with other robots and you need your robot to hold its ground. And otherwise, speed is very good for everything, makes everything you're doing faster. So 4-inch wheels with a 40-to-1 gearbox is a very common setup. It's a very even mix of speed and torque. And a 20-to-1 motor will have a very competitive speed.
So, in summary, you want to make sure to analyze your game and decide what objectives you want to complete. Then consider your different chassis types and choose which one will fit your needs the best. Then consider the amount and placement of your motors. And then make sure to make a hand drawing of your chassis so that you get everything right and that you make room in the center of your robot for intakes and things like that. And make a strong structure to protect against ESD and have a low center of gravity to prevent tipping.
All right, here are resources for the visuals used in the presentation. And now, any questions, anything anyone would like to say, please come up and talk to us. You may also come and look at our robot or the wheels that we brought. So, and you may also leave if you have something else to do. Go ahead. Yeah, so ESD, it's hard, but a lot of times it will be covering metal surfaces that you have exposed on your robot and prevent. Like, there's a lot of different options. Anything that would cover it that's not a conductor, like you could use electrical tape to cover something. Are you talking about the gearbox, the ratio? Um, Last year we ended up going with the 20-to-1 motor because we did want to have better speed, and it did give us enough torque to accomplish what we needed to do.
So that is with the Andy Mark Neverest
Yeah,
motors.
Andy Mark Neverest is the brand motor.
Yeah. So to add on to that ESD thing, so like what you can see what they did was they added plastic on the outside of their robot. It looks good, but it also like is not a conductor. So then if another robot bumps into you or something, then the static doesn't go through to the metal. Another thing is that you want to make sure it's a little bit complicated, but the material of the field and the material of the wheels, if they're like closer together, it creates less static. So there's like static charts online where you can see what materials conduct static and stuff. So while looking at your wheels also, you want to like make sure like maybe a mechanism wheel with metal might not be the best option because it's a conductor and it'll build static through the rubber and then go through the mechanism wheel to your robot. So you want to look at stuff like that.
Thank you very much. All right, go ahead. So most often, just the standard wheels are using a combination of the traction wheels with just a rubber outer layer all around them, and the Omni wheels, which allow for a much easier and better turning radius for your robot. So those are the common ones you'll see on standard tank drives, or those are the ones we used last year. All right, if you have any more questions, okay, yeah, just you may come up and talk to us now. You can come and look at what we have. So thank you. Absolutely.
So I walked in time to hear the question about wheels and static. There was a post on the FTC forums from 2 or 3 years ago where a team did a study of static and the materials, and so they the coefficient I don't recall the name of. The last time I tried to recall the name, I got it wrong. But if you search for, I think, ESD, you probably have searched for more than that in the FTC forum because they don't let you do small searches. You could probably find that thread. The one takeaway that our team had from that thread is that The wheels, the black wheels sold by Servo City, actually had the closest match to the properties, the static properties of the official FTC mats, and therefore generated the least amount of ESD. That's from memory, though. But you can probably locate that article if you are diligent in searching the FTC forums, and that would tell you more. So.
Yeah, thank you. So there are good resources out there. It is a pretty complex problem, but people have overcome it, and there are people to talk to out there.
Class dismissed.
So this might be just a really ridiculously basic question, but so you said the rev expansion next workshop is at 11:40. Tell you what, that was a big challenge for us this morning. I don't know how to and we had to actually turn the radio into like just because you have to get it in the corner of this. This is less good. But I mean, this part of it right here, like this map, that might change. It's a habit. It's a habit in all of us. So I'm just like trying to get which is going to have to show it. Let me look. I know it's wrong. $10 points. I'm sorry, 10. Who gets the 10 points? Yeah, so it's 10 points to get into the building zone. With these two all have equal height, and they're five inches tall.
Sorry, archers. Right.
You guys are way ahead of me right now.
He's like,
But see, that's 25 points. Okay. Be careful. We actually all right. Okay.
it has to be on the.
I think so.
Okay, so who's asking me about those? Who was asking me about the checkers?
It is the nightlight crew is exploring the field. We do have 10 minutes.
Okay, so it is 1 point if you go into your own spec. It is 1 point. Correct. It's 0 points if you go into neutral, and it's -point if the stone comes back out. don't get to keep that point.
So,
Wait, did we ever figure out if you can move the platform from this side to the side of the viewers? Yeah.
I don't think that's allowed.
I bet it's not.
I bet it's not.
We're talking about pulling the loading foundation
Under the.
under the bridge.
I guess we have to see if there's a.
If it's allowed, they'll probably make it.
Oh, I'm sure.
Oh,
yeah.
Yeah. Oh yeah. They're gonna be like, wait.
That
Wait
definitely
a
changes the
minute.
game a
Good
lot.
strategy. No.
Also driving. Yeah. Do you want to head over to?
Oh,
the
here it
phone?
is. Here's your penalties. The foundation movement is, if it's not completely in the building zone, it is -5 for every 5 seconds it's out.
Oh.
So if you bring it over here, you're going to start deducting points.
Yes,
I
very,
think
very
it can
different.
accidentally hold it for 4 seconds and it's not a problem, but every 5 seconds it starts counting. It's a minor penalty, but
Oh, that. All right.
can add up. Good to know.
So it looks like they counted for that.
Yeah, and here's the stepping over the sky bridge is the penalties on that.
Any feels on that?
You don't want to do that. Stepping over the first time it's a warning, the second time -5, third time -20, the fourth time it's a yellow card.
Like if you're going to pick up your
You are, yes. The refs are going to be monitoring that, and I'm guessing they can't keep track of which kid, so it'll
just know.
probably per team.
Sure, probably,
The
yeah.
first time the team will get warned, the second time it'll be -5. It's -5 just because of the safety. It's the safety and the credit. You can't do that. I can't stop it today.
And then I was just like that and just went forward slides. And I'm like, hey, it's not working. And then we were just like, this first. Slow down, like a little bit. You did fine. You did fine, but slow down, be more relaxed.
You did very good.
Oh, thanks, bro. Appreciate
You
it.
sounded very comfortable.
Yeah, I'm probably about the same as you. Like emotionless audience. Yeah.
It's a good time. I don't know why.
No, no.
You didn't think that was like very fun.
Seven.
So we have time.
Hello, everyone. So my name is Aiden.
And my name is Sam.
We're members of 11260 Upper Creek Robotics. We're going into our 4th year as a team, and we're here to give the workshop on chassis design.
So the first thing you want to do when deciding what design you want to use for your chassis is to analyze the game and figure out what elements of the game you want to complete. So for example, last year's game, Rover Ruckus, you had to get minerals out of the crater. And so for that, we decided to drive into the crater, so you might need a base to accommodate that.
Sorry, I'll go back so you can read that. Okay, so when you're considering your drivetrain, when you're designing it, you need to think about how many motors you will allocate to the chassis. And this is essentially how big of a factor your chassis is going to be on your overall robot. If you're doing tasks with your chassis, such as pushing or driving over obstacles, as we did last year, and how complex the other mechanisms will be, like how many motors you think you'll need for different lifts or other manipulation mechanisms. So we brought some examples of different wheels that there are in FTC and different options that you have. So the first wheel option is the traction wheel, which is the very simple wheel that there's a narrow one and a wide one, and there just are rubber coating on that side, the most basic wheel. Omni wheels are also very common, and they're omnidirectional wheels. They have these sliders that rotate parallel to the wheel, so the wheel can move side to side freely. There's nothing keeping it in place side to side, so that is much less traction on the ground. And last of all is the mechanism wheel, which has its rollers on a 45-degree angle. So it's a bit complicated, and we can talk about this after the presentation, but using mechanism wheels, driving each one individually, you can have your robot strafe right or left, in addition to just going forward or backwards.
So next we'll go over the different types of chassis.
And we'll have a question session after the chassis, so everyone's clear on everything.
So the first type is the tank drive. So the tank drive is the most simple chassis and one of the most common. So the pros are that it is very reliable, but it is less maneuverable than other types of chassis. So there's 3 different types of tank drives. So the most complex is the West Coast. So this has 3 wheels on each side of your robot, with the one in the center at a lower point than the other 2, which acts like your robot is tipping. And so this allows your robot to turn while also maintaining good pushing power. But it is, again, more complex than other tank drive forms. So the next is the skid steer, which uses 2 traction wheels and 2 omni wheels, which allows for good turning, but it does have, and it is simple to build, but it is a tank drive, so it has less maneuverability. The last is a standard tank drive, which has 4 omni wheels in each of the 4 corners, which allows your robot to turn on the center of your robot, but it does allow your robot to get pushed side to side because all of your wheels are omni wheels.
And this tank drive is probably the most common drive you'll see out there in the FTC world. Next we have the mechanism wheelbase. So that has 4 mechanism wheels, 1 on each corner, and they're individually powered by their own motor. And by driving one side towards each other, the 2 motors towards each other, and the other side, the 2 motors away from each other, it allows your robot to strafe, go a lot more maneuverable because it can go straight left to right, and as well as the normal forward and backward capability. And otherwise, it's pretty similar in structure to a tank drive, just using slightly different, slightly larger wheels.
So next we have a holonomic or X drive. So this is a drive system where you have 4 omni wheels in each of the 4 corners of your robot, but they're angled at a 45 degrees. So this allows your robot to move in any angle. But this does not have good pushing power, and it can't drive over some objects such as the crater.
All right, an H drive or slide is not a common design. You won't see it on many robots, but it essentially is a tank drive with 4 omni wheels in each corner, and then it adds a perpendicular omni wheel to the center of the robot, and that allows for just an added strafing capability that a tank drive wouldn't normally have, but they can be pushed pretty easily in most directions. They require an extra motor to power that extra wheel, and there's a lot less space in the middle for building everything else you want on your robot.
So next we have alternative drive types or game-specific drive types. So first we have bogey wheel bases, and that's what we have here. So this allowed us to go over the crater in last year's game while not moving our entire robot up and down too much. So this allowed us to get in and out of the crater very easily while collecting minerals. So then we also have a swerve drive, which is a very complex drive system which allows you to move in any direction, but it does take more motors and is generally heavier.
Yeah, and for our bogey wheel base last year, we had 8 wheels total, 4 on each side, and each pair of wheels was connected by like a V bracket, and the pivot point was at the top. So yeah, the wheels can move up and down independently of moving the robot up and down. Does anyone have any questions about different drive systems? Anything that would be good to clarify? Yeah, go ahead.
Would tank treads be possible?
Yes, tank treads are possible. Again, they're not as common as wheels. They're just bigger and a little harder to move, but yeah, they give a lot of traction, and some teams do use tank treads. We powered the traction inner wheel, actually. Okay. Any other questions? Go for it. Yeah, the mechanism wheels, in general, most of the ones you're going to find are quite a bit wider and quite a bit heavier than the other wheel alternatives. All right. So an option for your chassis is to get a commercial off-the-shelf chassis. So that's one that a manufacturer's made, and you can just order it, have your chassis, be done with that, don't have to worry about designing it or anything like that. So it's the fast and convenient way to do it. Well, here are some retailers that sell commercial off-the-shelf chassis, which are Andy Mark and their Tile Runner chassis, or GoBuilda or Servo City chassis. But with these, you'll have a lot less customization because they don't always sell all of the types of drives that we mentioned, and if you want to adapt it specifically to the game, it's good to build your own. And also, they are quite expensive. It's probably hard to read up there, but they're about $600 to buy straight from a manufacturer.
So once you've decided which chassis you want to go with, you want to make a hand drawing of the chassis to see where everything's going to fit and to make sure that you have room in your robot for other mechanisms such as an intake or a lift. And then you also want to make them full-scale drawings, and then so that makes it a lot easier when you're prototyping and building your chassis. So here's an example of a hand drawing.
All right, so here's drivetrains. Your drive, the way you connect the motors to the wheel, to powering the wheels, can either be done with gears, chain, or belt, are the most common options. Gears are very simple, very easy to understand, and you can change the ratios between gears very easily by using different sizes. But gears, under certain high stress situations, they can have damage, especially plastic gears. Chain is a very good option. It's very easy to get an exact length on chain, and it will generally stay tight, but you might need to add other things. You'll need a chain tool to manipulate chain, and you may also need a chain tensioner to keep the chain as tight as you want it to be. Sorry. Belt drive, last one. So belt drive can either be an external belt drive, which is going over all of the wheels that you have on the side of your robot, and that would be like how a tank tread would work. And it could also be just a replacement of chain to connect 2 points while they're spinning.
So when you're building your chassis, you want to make sure that your motor placement is good so that it leaves room in the center of your robot for mechanisms such as an intake, and it evenly distributes weight across your robot.
All right, So structure, chassis is a crucial part of your robot, and you really need to think about how sturdy and reliable it's going to be throughout the season, because it is not something you want to have to go back and repair or rebuild it because it's not holding up during a competition, harder to access, and it's supporting everything else on your robot. It's important to have enough crossbars to add structural integrity to the base. C channels, which are metal with two perpendicular metal pieces coming out. I'm sorry, I didn't describe that very well, but those are a good building option. The C channels are very easy to buy from Rev or any manufacturer.
So again, you want to make sure that you leave room in your robot for mechanisms, again, such as an intake or a lift, so that you don't have your motors in the way later on in your robot, and then you realize you can't fit your intake there because your drive motors are in the way.
Okay, so electrostatic discharge, or ESD, is a problem that everyone will likely come across at some point in their robotics careers. Most teams, struggle with it, and it's a big combination of a lot of factors. So electrostatic discharge can build up on the electrostatic energy, can build up on the field because of the foam and wheel materials, and oftentimes when exposed metal on your robot touches exposed metal in the field, there can be a big discharge and it can disconnect your robot, leaving you useless for the match. And it's a very complicated, like multifaceted problem, but some good approaches are to cover exposed metal, as we did with polycarbonate plastic that we have on that side of our robot. We could use electrical tape to make sure that the metal surfaces are not coming into contact with the field elements. And for like a more in-depth look at electrostatic discharge, every team deals with it, so a lot of the advanced teams have figured out things like which wheel types are ideal for reducing the creation of electrostatic discharge. So that's a resource to consult on the forums.
So the last thing you want to consider when building your robot is the center of gravity. So if you have long arms or other things, then you want to be conscious of tipping your robot. So you just want to make sure that your center of gravity is low and in the middle of your robot.
Okay, also for your drive, you need to decide whether you want speed or torque. Those are inverse relationships. If you have more torque, you'll have less speed. More speed is less torque. And you need to find the right balance that fits your robot. So torque, you'll need a certain amount of torque to move your robot, and even more if you think you'll be getting into pushing with other robots or going over some obstacle that's more demanding on your drive. And then speed is good for doing everything faster. Is otherwise a very good thing to have. It's just an example of what a lot of teams use. Using 4-inch wheels with a 40-to-1 gearbox will produce a very balanced, very standard mix of speed and torque. And a 20-to-1 gearbox is a competitive speed. Those are high-speed motors.
So in summary, you want to make sure that at first you analyze your game and figure out what objectives you want to complete. Then consider your different chassis types and which ones will suit your interests the best. Then make sure that you know how many motors you're going to use and the placement of those motors. And then make hand drawings of your robot so that you know where everything's going to fit and make it easier to build. And then create a strong structure and one that will prevent against ESD and tipping.
All right, here are resources for the images we used in our presentation. And now it's time for any questions anyone has. Go for it.
Can you go back to the hand drawing slides?
Absolutely. There we go. Yeah. And there are better examples out there. This is a decent image of one, but yeah, that's a good thing to ask about in forums. Yes, go ahead.
Could you go back to the resources slide?
Yes, absolutely. Go ahead.
Will your slides be available on the Colorado FTC website?
Yeah, I believe so. We'll make sure that happens. Good.
What do you mean by intake? I keep hearing that term today,
Intake, you said? So intake was like using an intake brush system was a way of gathering game scoring elements into your robot, and it was very common last year. So like ours, we have a brush intake where rods with brushes on them will spin and push the minerals from last year into our robot, into a holding mechanism.
So as you see, this takes up a lot of the real estate on the front of our robot.
Can you talk about the difference between like set screws versus clamping hubs when in the use of the prep chain?
So set screws on like a yeah. That is something I don't think we have a lot of experience on. We did use set screw, or we used bearings that have set screws in them to tighten and keep that's what we used on our shafts to keep them where we wanted them to be. But yeah, clamping is another option, and that's something we don't have expertise in.
I guess it's more relevant with like these shaft hubs versus the hex.
Yeah. We used hex shafts and hex shaft hubs. Sorry. Mechanism wheels? I'm not positive about that. You could go on to any mark or any retailer. They'd likely be just a little more expensive than the Omni or traction wheels.
It also depends on the brand and the type. So there's different types that will, like some have metal on the outsides for better structure, and then some are made of mostly plastic, such as the Vex ones. And I'm guessing those are much cheaper.
Yes. Sorry.
What is the advantage of Omni wheels over traction wheels?
So Omni wheels, the advantage you have there is it reduces traction, which is very helpful when you're turning. So for example, if you had a tank drive that had a traction wheel in every corner, it'd be very difficult on your motors to turn it by powering one side over the other. Omni wheels allow for a much tighter turning radius and a lot of strain relieved from your robot.
So generally, a good balance of the two is a good way to go if you have more than 4 wheels.
Okay, so that concludes our presentation. Any more questions, we can absolutely answer them. Otherwise, if you want to come up here, take a look at our robot or the wheels that we brought, talk to us at all, please go ahead and do that. Thank you.